Good morning, and thank you all for joining today's Science, Conservation, and Humanities lecture presented by the New York Botanical Garden. My name is Charles Zimmerman, and it is my pleasure to welcome you from locations across the United States and around the globe to today's webinar, Schrödinger's Phenotypes. How good is morphological data harvest from herbarium specimen images? At any time during today's event, please feel welcome to submit questions by clicking the Q&A button at the bottom of your window, and our host will raise these for our speaker to answer at the end. Live captions can be enabled by clicking the CC button, then show subtitles or view full transcript. This event is being recorded, and it will be shared on the NYBG lecture library by the end of next week. Now it is my pleasure to welcome today's speaker, Dr. Leonardo Borges, Professor of Botany at the Universidade Federal de São Carlos in Brazil. Dr. Borges' research focuses on the classification, morphology, and evolution of the sensitive plants and related genera in the legume family. He has conducted his research at NYBG multiple times during his PhD and also as a postdoctoral fellow. For a time, Leo also ran our seminars program and was one of the first to join our science and humanities events, and in some ways has led to the progression of the program we're still using today. So in his spare time, Leo also enjoys making wonderful drawings and ramen. So everyone, please welcome Dr. Leonardo Borges to the stage.
Hi, good morning, Charles. Thank you so much. Good morning to everyone else here today. It's a pleasure to be here. As Charles said, I've been part of the New York Botanical Garden seminars, and it's always good to be here again as a speaker and as a friend of many of my colleagues that work at the New York Botanical Garden. And in my my previous talks, at the seminars, I have talked about plant diversity, which is probably a subject that it's of interest for many of you guys, and I'm going to be talking about that today as well. And if you are interested in biodiversity, you're likely interested in specimens, either be those large vertebrate specimens like from this blue whale, which is in the British Museum, or even if you're more interested in plants, which are going to be talking today, like those very small, actually smallest plants in the world, you're going to find a specimen in a herbarium like the Botanical Garden. And in fact, those specimens, which are represented by millions in many museums and herbaria, are our main source of information about the biological world. And if you want to know more about where a species occur, how it looks like, what it does, this information comes mainly from herbarium specimens. And the thing with museum specimens, as well as herbarium specimens, and the thing with those specimens is that if you want to know more about them, you have to be in the museum or in the herbaria, and you have to open all those cabinets filled with plants, pull out specimens, take a look on them, examine them, and take out the information you want from them. Of course, things have become more easier for us right now, especially because we are digitizing these collections. The New York Botanical Garden has been doing a great job in doing that. And the thing is that digitizing plant images is so much easier than other organisms as a whole. So imagine if you have an interest in those blue whales. If you want to digitize that, it's going to take you a lot of effort, a lot of money, and it's going to take some time. But as plants, they are usually pressed and flat in very regular size papers. They're very easy to image, and we can produce hundreds, millions of 2D images very fast. As an example, we can take a look at the French National Herbarium. They were able to go from around 1 million specimens to 5 million specimens digitized in more or less 2 years. So of course they used a very complex system to do that, automatic system, but that's pretty fast. It's 4 million images in 2 years. And now we have all those plant samples that were only available in the French National Herbarium, you would have to get a ticket to France, ask for them to get into the herbarium. They will probably not let you go inside unless you gave them a very good reason to do that. But now you can just go to their website, take a look on the images, and do whatever you want with that. And of course, because we have all those million specimens available online, and not only from this herbarium, but from many other herbaria around the world, from Brazil, from New York, from England, from Australia, we can actually use those specimens and extract information from them so much easier. So getting data out of those specimens that were once just closed inside those cabinets is much easier right now. And you can extract different types of data. I know that people have been talking in this seminar series about what we can do with this whole information we have available now. And you can take a look on the previous seminars people have been talking here. Perhaps Charlie can share a link for that. But today I want to talk to you about morphology. And one thing that we can do pretty easy with those images is just to get some measurements out of that. In this example, in this image, for example, I'm just like measuring the length of this leaf blade. You can go online and do that. There are different ways to do that. We are developing, not me specifically, but people have been developing programs that can read the images and identify leaves, identify flowers, and extract information from those specimens. But those things are still underdeveloped. So the easier way for you to get morphological data is just to go take a look on the specimens, see what you want, and extract this data by yourself, as if you were in the herbarium studying the specimen. But of course, there are some issues to do that with images. The first issue that appears is related to resolution, because we are working with images now, and images depend on the quality of the camera you're using to generate them. Then if you're using a good professional camera, you're going to have a very good picture. If you're not, perhaps your picture is not going to be that good. And that's going to affect how you can identify different organs in the image, especially if they are very small. So in this case, we have this nice picture of this specimen from a mimosa from Brazil. And you can see the leaves, you can see that the flowers are here. And already you notice that the flowers are very small. So if you want to study the flowers, you have to zoom it. And then if you have a not quite so good resolution for the size of the feature that you are interested, then you're going to run into some problems. Another issue comes from the plants themselves, because sometimes their own nature hides some features. So let's say you want to study the morphology of some artichokes. You can go browse some images online, and you're going to know a lot about the leaves. You can measure their size, you can check their shape, you can see that they have some spines. But if you're interested in studying the morphology of the flowers, then you're going to run into some problems, because the flowers are nested within the inflorescence here. And while if you are in the herbarium, you can just like chop this inflorescence open, take out some flowers and study them, you can't do that with images. So we have at least those two problems, one related to resolution that is gonna difficult the study of smaller organs, and also this problem related to the nature of the plants themselves, which will have some parts, some organs hidden in different parts. So in order to try to understand how those apparent issues affect what we can do with images when we want to extract morphological data from that, me and some colleagues, we've asked two questions. First, we wanted to know if measurements that we take from the images are really good in comparison to measurements that we take from the specimens themselves. And also, we wanted to know if data collected from the images, when we analyze this data, if the results of those analyses are also good and in comparison to the analysis we do with specimen data. So before like getting into how we did that, how we tried to answer those questions, I need to establish with you some words that I'm going to be using, because they may mean different things for different people. So the first word we have to agree upon with, is precision. So I'm going to be talking about precision a little bit, and to me, it means the variation between different measurements of the same object. So to exemplify this, let's say we measure this leaf here. It doesn't matter if you measure the specimen or the image, but you took a measurement from this leaf and multiple measurements. And then you're going to check how close they are to each other. So let's say we measure one time, it's 56.39, then 56.20, and so on. And let's say we measure this with another tool, then we notice that one time is 56, another 54 or 58. So here you have the numbers more close to each other. So it means that no matter how you got those measurements, they are closer to each other than those here. So here we have higher precision, right? And so when we measure multiple times the same thing, the exact same thing, and we got consistent numbers, that means that we are doing this very precisely. Another word we have to talk about is accuracy. And accuracy is a measure of the difference to our reference, right? So it's how something differs from established gold standard, let's say. So of course, this is like relative, relational. There is no definitive measure of accuracy. It's always in relation to something. So let's say we go to the herbarium and we measure a specimen, this leaf here again, and we see that it's 56 millimeters, right, in length. And then I'm going to take a look on the image. If I take a look on the image and I notice that it's like 56 multiple times, that means that the measurement that I'm taking from the image is very accurate, because it's very close to the one that I set as a gold standard, which was the measurement of the specimen itself. But if I was measuring the image and I noticed that all my numbers, all my measurements are 54, a little bit different from the 56 that I established, then I have a drop in accuracy here. It's not as accurate as in this case here. And note that you can be less accurate, but still precise, right? Because we measured this multiple times and we notice that they are all very similar. That said, we can go back to those answers we made and try to see what we find. So to try to understand the relationship between measuring features, morphological features in images and specimens, what I did was to go to the herbarium in the Rio de Janeiro Botanical Garden. I chose 5 species that have different leaf morphologies, and that have many specimens in the herbarium. And that's to be sure that we were not finding patterns that were not related to the things that we were measuring, right? We had a good sample of leaves. And then I took one specimen, many specimens, and in these specimens, I would measure one leaf. Let's say in this Inga here, I would measure this rachis, and then the length of the leaflet and the width, for example. Then I would go to the image and do exactly the same. I would measure the exact same leaf, the exact same features. And then we would compare the measurement from the images and from the specimens to see what happens. And the first thing we saw was that measuring images and measuring specimens is pretty similar in precision. So here in this graphic here, we have size here, and we have the relative precision here. And that means that the lower the relative precision value, more precise is your measurement, right? We did that because we measured a variable like leaf length twice, both in the images and then in the specimen, and then we compare those measurements made multiple times. And we see that this curve follows the same trend. It doesn't matter if you're taking measurements from the specimen in blue or from the images, right? And one thing that we notice as well is that this precision, it kind of drops with size. Like for smaller traits, we have lower precision. And that's pretty obvious. If you're using a tool, and we were not changing tools while taking those measurements, it's going to be good for a particular range of size. You cannot use like a 15 centimeters ruler to measure your wall, right? It's going to have some problems to do that. It's the same here. It's just an effect of the tool we were using. And another thing that we saw is that measuring images is very accurate. And that's what those graphics are showing. Here below we have the specimen measurements, and here we have image measurements. And then we're just plotting measurements taken from both images and specimens in those graphs here. And this, when does those dots fall over this blue line, that means that very close to this blue line and close to each other, that means that they are very close to each other. That means that if you measure one thing in the image and you measure the same thing in the specimen, and if everything is falling over this blue line, they are essentially the same. And that's what we see for many of the variables that we measure in the leaves of those plants. Of course, we have some things that are not as accurate as others, and that's going to vary from the species, because of the species you are taking a look, and also the measurement. Remember that we have this drop in precision here. Take a look, we are measuring things that are not as big as other things that are very precise. We could ask the same question in a different way and kind of trying to see how difficult it is to differentiate measurements taken from images from measurement taken from specimens. And that's what those graphs here are showing, right? So if we take a look on the difference between specimen and image measurements, if they are very close to each other, this difference should be 0. And if you take a look of the number of observations that fall within this line, we see that most of them are actually 0. So measuring specimens and images is pretty much the same for most part of the time. But of course, not everything is perfect. And once again, we see that accuracy, as we saw with precision, drops for smaller traits. So here we again have size here. So for larger features, let's say we're measuring a big leaf, we're going to be accuracy is going to be very good. But as we start to measure smaller organs, then accuracy is going to drop, and then we're going to start to see differences between measurements taken from images and from the specimens. Here is an example of what I've just said. So for this species here, if you measure the leaf blade length, everything's perfect. Everything's falling on top of the blue line here. The same for blade width. But if we're interested in measuring this very small structure here, the petiole, then things start to get a little bit messy. And that's what we are calling size-related noise. It's just a measure of how things kind of get blurry when you start to measure smaller things, usually below 30 to 40 millimeters. So that was an evaluation of the difference between image and specimen measurements. And now we can go to the second part of this talk, which is related to the quality of analysis based on image data. And to evaluate that, what we did was to find lots of legacy data sets from studies that compile morphological information from specimens. And then what we did was to take those data sets and use them to simulate data sets as if they were collected from images. And to do that, we added size-related noise to the variables. So let's say we have like a variation in the sizes on the leaves. We added some noise, so it gets kind of blurred. And that noise was based on the analysis we did to show what I just mentioned before. And we also evaluated which one of the variables within each of those studies could be observed in images from the same species. So let's say for this Eugenia here, one variable was related to some feature of the flower. I would go online for many specimens and see, can I see this feature? Can I see this morphological trait, let's say the stamens here in this flower? Yeah, I can. So we are going to keep this in the data set. Oh, I can't because the flower, it's always closed and I can't measure the stamens. So we would exclude this variable from the data set. Sometimes we could see one feature in one image, not see it in another image. So we try to input this variation in what can be and cannot be observed in images. And so we had, after doing that, we had a second data set, which was a simulation of the collection of the real data sets as if based on images. And then we compared the original data sets with the simulated data sets using a principal component analysis. I'm not getting to the details of what is this analysis, what it does actually, but it's a very commonly used analysis in studies of morphological variation, especially because it can accommodate multiple variables. So in general, we ran this analysis for the data set, the original data set, and then run it again for the simulated ones and took a look on how they differed from each other. The first thing that we noticed is that missing data is very common. So if you are using images to collect data, morphological data, there are things that you were not going to be able to collect. Of course, as we already saw, that some is part of the plant's nature, of the specimen's nature sometimes, because things are just pressed on top of each other. And this table here shows like all those data sets that we collect and shows the amount of missing data we saw for each one of them. And you can see here that missing data occurs for almost everybody. We had like 2 data sets that had no missing data at all. And this is related to the type of morphological features that the authors of these studies were studying, and also to the type of plants they were interested in studying as well. And if you take a close look on this table, there are no real pattern that is shared among the different studies, while some of them may have a large number of total percentage of missing data and others kind of less. Others are going to have like larger numbers of variables that are completely absent from the data set if you use images. So although there is no real pattern here, because it's going to depend on the type of plants you are studying, one thing that we notice is that missing data is really more common in continuous variables. So if you're measuring things, that's going to be a little bit more problematic than if you are just taking a look on, let's say, categorical information like the number of leaflets in a composed leaf, or if you're looking at discrete information like the shape of the leaves, for instance. And then here we are going to see how those 2 data sets behave in relationship to each other. And we did that in 2 different ways. One thing was comparing the whole PCAs from the regular analysis and the simulated ones. And another way was taking a look on particular components of each analysis. And the way you have to interpret those graphs here is just looking at the lines where those 3 dots fall. So if they fall here close to 100% line, that means that the original data set and the simulated data set generate the same results in the PCA. But if the dots change places, then that means you are having you are losing accuracy in the analysis, right? So let's say here we have a drop of 0.5% in accuracy. And we did that for all those data sets, but let's take a look on the general trend that we observed for this comparison. One thing that we noticed is that noise, the size-related noise, is not really a problem. In this example here, we see that these dots falling almost near the 100% line, meaning that we don't see a drop in accuracy here. And if you only included missing data in the simulated data sets, we have a stronger drop in accuracy. I forgot to mention here, but we did that 3 times. So we have simulated data sets that only included noise, simulated data sets that only included missing data, and simulated data sets that included both things. And this is kind of a more realistic view of what's happening when you are collecting data from images. So noise is not much of a problem here, but if you go and take a look on what missing data does, it really drops accuracy in the results of the analysis. And also noise and missing data can interact to drop accuracy a little bit more. Usually this is gonna vary, but in general, we didn't see for the data sets that we studied drop in accuracy that was above 25%. And depending on the case, that's good. Depending on the case, that's bad. This is gonna be something that if you are interested in collecting data from images, you're gonna have to evaluate by yourself and see if how that fits into your question. And here, you probably noticed that the 3 dots are all falling in the 100% line here. And that's just because this was one of the data sets that had no missing observations at all. That reinforces that noise is not really a problem. And if you have a data set that has no missing data, you can just use images to collect, to base your analysis. Okay, so that brings us back to the title of this talk, in which I asked how good is morphological data collection from images instead of from specimens. And if you know something about Schrödinger's, you're probably guessing what we're gonna find out pretty soon. But before that, let's take a look on what we found. Let's just make a summary of what we found. First, if you want to measure images, it doesn't matter. It's a very precise procedure. It's very accurate, so you can measure both. Can measure images instead of specimens, but you have to know that accuracy drops with size. So if you're measuring smaller things, then perhaps you're going to have a drop in accuracy. And also, the results of analysis based on the data you collect from images is pretty good in general. But it has some problems related to missing data, which is going to affect the accuracy of the analysis. But of course, not much. It's around that 25% line that I mentioned before. So, in conclusion, it's pretty good to use images to collect morphological data. But at the same time, it's a little bit bad. It's not too bad, but that's going to depend on what you're going to do and what's your goal with the data you are going to collect from the images. So because of that, you have to take care with small sizes or small species. Everything that is kind of below this 40% millimeters size, you have to take care with. And of course, this is going to depend also it's going to depend on the resolution of the images you are using. But as I mentioned before, resolution varies among institutions. So in some cases, you're going to be able to measure smaller traits very easily and very precisely and very accurately. But in other cases, that's going to be a problem. Missing data also is a problem, but there are some solutions for that problem. We can, for instance, use data imputation. It's a technique that takes a look on the variables within your table and try to infer, try to fill the blanks you have in your data table based on what you're seeing around those blanks. Data imputation is good, but it also has some bias. So you have to be aware of that if you want to use this method. And of course, you can also always exclude some variables. If you see that something that you wanted to measure or observe, it's very hard to do. You can just not collect this data. And of course, the decision not to do that is going to depend on what is your goal in your research. And a more kind of hybrid approach is to start collecting data from the images and then fill the gaps with specimens. Although not perfect, because you still have to go to the collections and work there. It's really much faster and it's going to cost less money. It's very efficient to do that. And as we saw, precision is not a problem. So you're not going to have this kind of very weird data set in which part of the measurements or variables are from specimens and the other part is from the images, and they kind of not relate quite well, because the measurements you take from images are pretty close to the specimens. It's okay, you're going to have a nice data set. So that hybrid approach is very, very nice. So in summary, we can just use images. They are pretty good. They're going to support reasonably good results. But you have to take care of that. If you're measuring things that are kind of problematic, take care with those measurements. If your analysis is suffering from a kind of high drop in accuracy, take care with that. Take a look first to see if these changes in precision or accuracy are not affecting what you can understand from the analysis, and check if they are not kind of hampering your conclusions. So it's always a good thing to try to make a trial first before you just go straight to the images, see if you have if you don't have problems, and then define how you're going to collect your data. Finally, I would like to end saying that everything that I just said is in this paper that we published kind of 1 year ago, more or less, if I'm not mistaken. And you can take a look on that. Charles is gonna send you the link via the chat for the paper itself, and also for a preprint. If you can't access this journal, you can take a look on the preprint. Everything that it's in the paper, it's in the preprint, so it doesn't matter. It's just gonna look different, but everything's there. So I just would like to say just would like to thank you all for being here today, and I want to thank Charles for inviting me to be here once more. It's a pleasure, and if you have any questions, we can talk about that.
Thank you, Leo. That was really terrific. It's always great to hear your voice and see your work. Thank you for sharing with our audience today. So it's now time for our Q&A. So everyone in the audience, please welcome to submit questions if you haven't already to the Q&A. You can use the Q&A button at the bottom of your screen. And if you see questions that others have submitted that you also would like to see answered, go ahead and click the thumbs up button, and that helps us prioritize those questions for Leo. But I think we have plenty of time. So Leo, I'll just get started with our first question. What program or programs are available for measuring morphology of digitally from specimens, and what program did you use in your study?
Well, that's kind of a tricky question, because there are many things being developed right now. I forgot to mention, but there are many different software to take measurements automatically. You can just input your images and it's going to find out what's a leaf, what's something that you're interested in, it's going to extract this data for you. But there are some issues with that as well, especially if you're interested in particular variables. I mentioned some of those options in the paper, so if you can take a look on that, that would be easier, because I don't have that on top of my mind. Me particularly, I just took the measurements, like with a ruler, a digital ruler, or a digital or a regular caliper for the specimen measurements, because we were really interested in knowing how the data that you get from those different sources is going to correlate to each other. So there are no need to use some fancy programs, but they are available.
Great, thank you. And yeah, again, so there's some things that Leo did that's presented in that paper, but there's a lot of tools out there I know image J is one of them that people use for doing many measurements in a row. Yep, I saw someone just posted that to the chat. All right, so next question comes from Robbie. Do any herbaria have mechanisms to capture specimen measurements in order to avoid duplicated work? So where do those morphological measurements connected to accessions tend to get stored? Are they in publications or supplementary material, personal data sets sitting on a hard drive somewhere? Is there ever a link out there from the Herbarium database to this data, or does the link always go to the other way?
Well, that's a very good question, and that's something we have to work to improve. Right now, I've never seen any digital collection that shares the raw data that was captured from the specimens online. I know that there are some initiatives, some people are trying to do that, to integrate things, especially through GBIF, because it's a kind of a good hub to connect collections and things that are being done with the data, but that's not implemented yet. And actually, that's something I've talked a little bit in the paper. We have those millions of images available right now, but it was very hard to find raw data for our legacy data set study. I mean, like, people don't even publish the raw data, and getting that back to the herbarium, then that doesn't happen, and it should have been like made available. It should be in the herbarium system somehow, or in some other system that connects everything with everything. There are platforms to do that, like Morphobank is a good place to find a morphological data set. But other than that, things are pretty much all around, not integrated.
I agree with you there. I think there needs to be a lot more work in terms of putting the data together and publishing it from herbaria or other resources that scientists use to obtain specimens. And I think this gets to the point of the extended specimen, which is a big project that's become a very prominent direction that Herbarium are trying to go, is bringing together all the information surrounding a specimen, the images, the measurements, the DNA, making that all unified and connected. It's a complicated task. There's lots to consider. The data is often structured in different formats, and it's not always shared back with the organization that was maintaining those specimens. So it is a huge lift, but I think it is the future that we're trying to do as institutions. So that's a great.
And one good thing about digitalization is because like every specimen now has like this barcode, so it's easier now to connect things. So that was a very important first step, and now we just have to build the environment where things are going to get connected. But yeah, you're right. We totally have to move in that direction.
Absolutely. So Mark had a question, which I believe got a little bit of some answer in the Q&A already, but the question was, is there a standard being developed for the digitization of specimens? For example, required resolution?
It depends. Sometimes it depends on the project that you have. Like, for instance, if the image is produced as part of the global plants initiative, like the JSTAR global plants, you have to use this kind of equipment that is going to produce images in this minimal resolution. So then you have that. And then you have like the New York Botanical Garden standard, and then the French National Herbarium standard. So unless I'm mistaken, maybe Charles know more, there are no minimum requirements. And also it depends on the budget herbaria have. Like, for instance, here in Brazil, not all herbaria have a lot of money to buy fancy photographic equipment, but they still want to get their images available online, because that already facilitates a lot of work. Like, I could go online and check an image from a herbarium in the middle of the Amazon, if there was any, and see if there is something interesting there, right? I couldn't perhaps collect morphological data from that image, but it's still a step towards improving the quality of the taxonomy that's based on specimens. But yeah, do you know anything about that, Charles?
Yeah, I was going to add, I think you really hit the point, is that I think organizations do what they can with the budgets that allow them, and sometimes there's a lot of specimens to image, sometimes they have very few, so it might not warrant purchasing an expensive device. But as the technology has evolved, the specimen images are getting better because organizations are tending to buy higher resolution cameras for their major digitization projects. It started to be that scanners were the best, and that's how we imaged all of our type specimens at NYVG. We used a scanner that was inverted, and so we were able to not flip the specimen over in order to get a really high quality resolution scan. But those scans took several minutes for each specimen. So it wasn't really a practical solution for imaging the millions of specimens we had to get through. So we switched to using cameras, and those cameras have gotten better and better. And also the lenses that the cameras have also produced better quality images. I can't tell you specifically about the image qualities that we use currently, but our digital asset manager can, Leanna McMillan. Also, I'll just highlight a comment in the chat. Someone mentioned MorphoBank as a great place to collect, curate, and share morphological data, matrices, and images. So it's good to know.
Great. Yeah, I mentioned it, and we even mentioned that in the paper. It's a very good resource. You can add images there. You can add a lot of stuff to MorphoBank, and then you have this project with a DOI, and you can share it. It's great.
Oh, and also it's worth mentioning, iDigBio is the US-based organization that is advancing digital collections and digitization of biodiversity specimens, and they have great recommendations for what kind of cameras to use based on what's currently available now. This is great. It's great to have so much time for questions. Thank you, Leo, for sticking around with us. So this is a sort of a multi-part question, so I'll break it down into a couple pieces. So do you ever use tomography to view internal morphology of plants, or do you know of how that's used?
I know it can be used, but it depends on the resolution of the machine, and also on what you're trying to look at exactly. Because, you know, for tomography, you need the tissue to vary in density. So sometimes you cannot have that, but that can be done. And people use that more for animals, because then you can scan the bones, and then you have those 3D images from the specimens. But usually tomography for plants is more used for specific questions. I don't know about any kind of project that aims to scan plants in this way. I mean, like consistently, you know, to have like a lot of data using this kind of platform, but it can be done.
Another technique that's more analog but still very technical is slicing to get through the inner morphology and the anatomy of the inside of plants. For instance, flowers can be sliced very thin sections and then looked at under a microscope. That's often done in order to see those features that are on the inside, if that research requires it. So one of our participants asks if they're interested in how plants shrink, I guess. It sort of depends. You're talking about making measurements on herbarium specimens, right?
Yes.
But I imagine it would be a whole different story if you're measuring from live plants.
Yeah, so there is a study, I don't recall it now, but they evaluated exactly that. They took a look on what happens with measurements when you use the live specimens, you know, and then the dried ones. And of course, they shrink in different rates. So it depends on the group you are studying. But if I'm not mistaken, it kind of doesn't matter unless you are comparing things that really shrink in different ways. If you're focusing on like a taxonomic group, on closely related species, you are not going to have too many problems. Of course, if you mix things together, then that becomes a little bit more problematic, because then you're going to measure a leaf and then it's alive, and then the size is going to change because you just measure something else that it's dry. So that's kind of a mess. Don't do that. You can send me an email. I can try to share this paper with you later. I don't know if I can share my email here, but can I? Maybe perhaps not. I'm not sure. Charles, what's the policy? Can do whatever I want.
If you want people to contact you, you're welcome to share it there in the chat.
Yeah, if you feel like, just write me, and yeah, just don't send me malware.
And on that topic, though, it's just reiterating, I think one of your results that was really insightful was that the herbarium specimen images and measurements from the herbarium specimens, those were relatively compatible.
Yes.
Because that's the kind of work that a lot of people are going to be doing. They're going to be combining those two data sets. So knowing that those two are similar precision and accuracy, I think benefits a lot of folks.
Yeah.
Great. Yeah, we also had just sort of comments about whether or not all herbaria will be fully virtual. I guess maybe that's maybe a theological question. Is there still value in having these herbarium specimens, or can we start transitioning towards just digital versions of a lot of our specimens that we have in archives?
Well, I guess we're gonna have to keep both. We're gonna have to keep both, because I mean, like, if you don't go to the field and collect more plants, you're not gonna have more things to image and to make them available. So I guess that's it's kind of a transition, but not a transition, because one thing, it's not replacing the other. It's just like making things more connected, expanding things. It's kind of what Charles mentioned, this kind of expanded specimen. It's just another way of seeing those biological samples.
Yeah, and Megan put a comment in the chat too that I think is worth saying, that you can't get DNA from an image, right?
Yeah,
there
totally.
are plenty of uses that herbarium specimens still maintain, whether it's gathering molecular information or just, sampling their chemistry. We know we can look at herbarium specimens and look at the amount of radioactive ions in them, and look at how that tells us about the what was happening on the Earth, the time those plants were collected, heavy metal accumulations, things that would never have been conceived of when plants were originally collected. We're still using those specimens for. So yeah, I think it's valuable to have digital archives. It's valuable to have images and scans when you have funding for it. But yeah, there's still value in those physical specimens for the long term, I believe.
And if I may say, like, one of the results of our work is that, like, we just pointed to this problem that it's kind of obvious that you cannot see everything that it's in the image because you don't have access to the plant. But we went there and we said, this is kind of a problem. And for some people, this is going to be okay. And an okay problem. For others, is going to be a huge problem. So if you image the specimen and get rid of it, then you can go and take a look on what cannot be seen on the image. So it's just that, it's just like complementing things and facilitating work. And once we have like very good programs that can extract morphology in a blink, things are gonna be like kind of crazy, but still the computers cannot go to the herbarium and open a flower. Someone still has to go there and do that. Of course, you can add a new level to that in which the herbarium itself provides images from like these things that you cannot see unless you dissect the specimen. And then we're going to just add more things to this kind of extended specimen. So maybe one day, but I don't think we're gonna get to that point that fast.
Thank you. All right, so I just have one more question for you. I think we're running out of time.
Okay.
What's next? What's your next project after this?
Yeah, well, the next project is to actually study the morphology of the plants, hopefully using images, you know, like that my main research line is not focused on this. This kind of paper came out of sheer curiosity, you know, like, because I noticed people were like talking about measuring plants and doing stuff like that. And I was like, dude, but is that good? So we just checked it out. So, and then we found out that, yeah, so hopefully we can use that for my own research with the sensitive plants. But unfortunately, as I showed, mimosas have very small flowers. So I don't guess you're gonna be able to rely solely on that. So hopefully in the future, I will have to go to New York to measure some specimens there. So that's gonna be great.
We'll always be here. Wonderful. And I'm sure this work is going to be very valuable for other scientists who work on, you know, plants with larger flowers and larger flower parts. So thank you for that contribution. It's greatly appreciated. So yeah, that'll be it for the day. Leo, thank you again so much for taking the time to talk to us about your research.
My pleasure. Thank you very much. And I hope to be here again in this format or in any other formats as soon as we can travel freely. And it was great to see some people like that I've met like in the chat. Huge hug to everybody, especially people that were special for my history of work in and together with the New York Botanical Garden. Thank you so much.
We appreciate that. Thank you also to our audience, and thank you for everyone for joining today's presentation. And as a reminder, if you missed any part of the event or wish to watch it again, a recording will be saved and shared on the NYBG lecture library. It should be ready by the end of next week. So we hope you'll join us for future science, conservation, and humanities lectures from the New York Botanical Garden. And for those who haven't already registered for our mailing list, go ahead and sign up using the link in the chat at the end. Till next time, please stay well, stay green, and take care. Goodbye, everyone.